Good day, everyone. First of all, I would like to thank the organizing committee for the opportunity to present our work. My name is Mireya Ovando Rocha, and today I will present a research entitled Machine Learning based on detection of air pollution microepisodes in the South Tamaulipas metropolitan area. This work was carried out through a collaboration between Instituto Politecnico Nacional, CICATA Altamira, Universidad Veracruzana, Instituto Tecnológico de Ciudad Madero, Universidad Tecnológica de Altamira, and our settings are Air Quality Monitoring Network, MOCALTAMA. Today, I will show high temporal resolution monitoring can relevant short-duration pollution events that remain hidden when conventional air quality assessment methods are used. Before presenting the methodology, I would like to explain why the research is important. The Sur Tamaulipas metropolitan area is one of the most important industrial regions in northeast Mexico. It includes petrochemical industrial, an oil refinery, commercial port, an international airport, and densely populated urban area. As a result, air quality can change rapidly throughout the day. Most of the air monitoring systems are designed to evaluate long-term exposure using the hourly or daily average. While these methods are essential for a public health assessment, they may overlook short-duration pollution events and also known as microepisodes. These events may last only a few minutes or a few hours, but they can still represent significant exposure for the population. Therefore, detecting these short-duration episodes is important because it provides additional information for the environmental management, support decision-making, and improves our understanding of air pollution dynamics. Based on this motivation, we formulate the following research question. How can air pollution microepisodes that remain hidden in a conventional air quality assessment be detected? Conventional air quality assessment is essential for evaluating public health and regulatory compliance. However, because it relies on average period, such as one of the hour, 8 hours, or 24 hours, short-duration pollution events may not be clearly identified. In this study, we explored whether minute resolution monitoring can provide additional information to detect and characterize these short-duration pollution microepisodes. This study was conducted in the South Tamaulipas metropolitan area, located in the northeast Mexico. This metropolitan area includes 3 cities, City of Tampico, Madero City, and Altamira, with a population of approximately 997,000 inhabitants distributed over an area about 93 square kilometers. The region has a tropical savanna climate, characterized by high temporal and high relative humidity throughout the year. These meteorological conditions influence the formulation, transport, and dispersion and atmospheric pollution. In addition, the metropolitan area contains one of the most important industrial and port complexes in Mexico, making it an ideal location for studying short-duration air pollution events. The map of the right shows the location of the study area within Mexico and the metropolitan region where the monitoring network was deployed. To monitoring the air quality in the study area, we use the MOCALTAMA monitoring network. This network consists of 4 air quality monitoring stations, strategically distributed across the metropolitan area to represent different environmental conditions. The station continually measures the main criteria air pollution, includes carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, and particulate matter 2.5 and 10. One of the main advantages of the network is the high temporal resolution. Measures are recorded every 1 minute, allowing us to capture rapid changes in pollution concentration that may not be observed using conventional monitoring approaches. The data are used in the study covers the period from October 2023 to December 2024, and it's openly available through the Mendeley data repository. This image illustrates that the continuous emission that characterizes the South Tamaulipas metropolitan area. The industrial corridor includes petrochemical facilities, an oil refinery, power generation, and port-related activities. These sources operate continuously and contribute to the atmospheric pollution load in the region. However, emissions are not constantly over the time. Their impact depends not only on the emission rate, but also on meteorological conditions, such as wind speed, wind direction, atmospheric stability, and humidity. Consequently, pollution concentration can change significantly within minutes, producing short-duration pollution episodes that may not be evident when only hour or daily averages are analyzed. This highlights the importance of continuous high temporal resolution monitoring to better understand the dynamic of air pollution in an industry metropolitan area. To investigate these short-duration pollution events, we use the Mocoltama Air Quality Monitoring Network. The network consists of 4 monitoring stations strategically located across the Sur Tamaulipas metropolitan area. Each station represents different environmental conditions, including industrial, urban, transportation, and mixed influence areas. This station continuously measures the main criteria of pollution, including the particulate matter, sulfur dioxide, nitrogen dioxide, ozone, and carbon monoxide. Unlike conventional monitoring systems that usually report hour or daily average, our network records data every 1 minute. This high temporal resolution allows us to capture rapid changes in a pollution concentration and identify short-duration pollution events. The dataset analyzed in this study covers the period from October 2023 to December 2024 and is publicly available through a Mendeley data repository. Before presenting the results, it's important to understand how air quality is conventionally assessed. In Mexico, each criteria pollution is evaluated using a specific regulation averaging period. For example, particulate matter are assessed using the new CAS methodology, while sulfur dioxide and nitrogen dioxide are evaluated using the highest 1-hour average. Ozone and carbon monoxide are evaluated using the maximum 8 hours moving average. These averaging periods were developed to assess population exposure and communicable health risks, and they are essential for environmental regulation. However, because these periods really are averaging over long periods, short-duration pollution events may become less evidenced or even remain hidden. For this reason, in this study, we complement the conventional assessment with minute resolution monitoring to better identify and characterize air pollution microepisodes. Effect of temporal averaging. This figure illustrates the same particular pollution even analyzed using different temporal resolution. At the original 1-minute resolution, we can clearly observe rapid fluctuation and short-duration concentration peaks. As the average period increased to 15 minutes, 30 minutes, 1 hour, and finally 24 hours, the concentration profile becomes progressively smoother. The pollution event is still present, but much of this temporal detail is lost because the average process reduces the variability of the signal. As a result, short-duration pollution episodes become much more difficult to identify using conventional average period. This demonstrates why high temporal resolution monitoring is essential for detecting and characterizing pollution microepisodes. Once we demonstrated the importance of high-resolution monitoring, the next step was to identify candidate pollution episodes. We first analyzed the complete monitoring report using daily particulate matter 2.5 heat maps for each monitoring station. This heat map allows us to rapidly identify days with unusual high pollution concentration and to determine whether the events occur at a single station or simultaneously across multiple stations. Based on this screens process, we select representative pollution episodes for detailed analysis. These events were chosen because they show high concentration, different spatial behaviors, and were supported by additional information such as CDC report or meteorological condition. After identifying the candidate episode, we perform a detailed analysis of the most representative cases. The first was one response to an industrial emission event reported on February 11, 2024. Our third case study corresponds to an industrial emission event reported on February 11, 2024. During the afternoon, residents living near the refinery reported a strong gas odor and observed a visible emission plume. The event was also documented by local news media. This independence report provides an opportunity to evaluate whether the monitoring network detected the event and characterize its temporal evolution. We first evaluate this event using the conventional air quality index methodology. According to the conventional assessment, air quality during that day was classified as moderate. However, local reports indicate that the event occurred approximately between 2 p.m. and 6 p.m. Therefore, instead of analyzing only the daily classification, we strict a 24-hour window, including 12 hours before and 12 hours after the report event. Using the minimum resolution data, we were able to observe the temporal evolution of pollution concentration in much greater detail. The first analysis relevant that not all monitoring stations behaved in the same way. Two stations recorded their highest particulate matter 2.5 concentration during the early monitoring. This indicates that different atmospheric processes occur throughout the day, and that not every peak was associated with the reported industrial event. This finding highlighted the importance of analyzing each monitoring station individually before interpreting the entire episode. In contrast, the air quality station of Madero Refinería and air quality station of Tampico Aeropuerto station researched their highest particular matter 2.5 concentration during the afternoon. This peak concentration occurred close to the time when the illustration emission was reported by the local resident. This temporal agreement suggests that the monitoring network successfully detected the reported pollution episode and allow us to characterize its evolution using minute resolution measured. To better understand the behavior of the episodes, we analyze the meteorological conditions before, during, and after the report event. The wine file chain throughout the day indicate different atmospheric transportation conditions. This chain helps explain why pollution concentration varied among monitoring stations and why the temporal evolution was not identical across to the metropolitan area. This figure illustrates the evolution of the wind file during the event. The analysis shows that change in wind direction and speed create conditions favorable for the transport and dispersion of pollution across the metropolitan area. Although the wind analysis cannot identify the emission source, it provides important meteorological context for interpreting the monitoring observation. In summary, this case study demonstrates how different sources of importance can be integrated to characterize a pollution episode. First, the event was identified and reported by local residents. Second, the conventional air quality assessment classified the day as moderate. Third, the minute resolution monitoring network revealed the temporal evolution of the episode. Finally, wind file analysis provides meteorological information that help explain the spatial behavior of pollution concentration. Overall, this case demonstrates that a high-resolution monitoring complements the conventional air quality assessment by providing a more detailed characterization of short-duration pollution events. The second representative case occurred on February 23, 2024. During this day, the monitoring network detected a regional particulate matter 2.5 episode affecting multiple monitoring stations. According to the conventional air quality index, air quality research categorized ranking from moderate to very unhealthy, depending on the average period. However, the minute resolution data reveals that pollution concentration changed rapidly throughout the event. Research maximum concentration of several hundred micrograms per cubic meter. This demonstrates that the high-resolution monitoring allows us to observe the temporal evolution of an episode and identify short-duration concentration peaks that are not clearly represented by conditional daily assessments. To better understand this event, we analyze the meteorological conditions during the same period. Meteorological observation indicates that this pollution episode occurred under fog conditional companies by very high relative humidity during the early hours of the day. These atmospheric conditions reduce vertical mixing and can favor the accumulation of particulate matter near to the surface. Although the monitoring data alone cannot establish the exact cause of the episode, the combination of high relative humidity, reported fog, and elevated particulate matter 2.5 concentration suggests that the meteorological condition played an important role on the evolution of the regional pollution event. This case illustrates how integrally air quality measured with meteorologically observed improves the interpretation to short-duration pollution episodes. Finally, I will represent the third representative case, which corresponds to particulate matter 2.5 episode observed on December 31, 2024. The third representative case corresponds to a regional particulate matter episode observed in this day. This event was selected because it was simultaneously detected by multiple monitoring stations across the metropolitan area, indicating that it was not restricted to a single location. The minor resolution data revealed a rapid increase in particulate matter concentration, followed by a progressively decrease over the following hours. This episode coincides with a New Year event activities. Although additional emission source has meteorological condition may also have contributed to observed concentration, this case illustrates the importance of analyze regional monitoring data to identify pollution events affecting large urban areas. The conventional daily assessment provides a general description of air quality during the day. However, the minor resolution data clearly relevant the temporal evolution of the pollution episodes, includes the onset, the peak concentration, and the gradual return to background conditions. This level of detail will not be obtained using only daily or hourly average. Therefore, minute resolution monitoring provides valuable additional information for identifying and characterizing short-duration pollution episodes. The three cases studied present today demonstrate that integrating high-resolution monitoring with meteorological information and independent observation provide more completely understand how air pollution dynamic. Finally, I would like to summarize the main findings on this research. To conclude, this study demonstrates that the conventional air quality assessment and high-resolution monitoring provide complementary information. Conventional assessment remains essential for the evaluate population exposure and communicate health risks. However, because it relies on regulatory averaging period, short-duration pollution events may not be clearly identified. In contrast, minute resolution monitoring preserves the temporal variability of pollution concentration, allowing the detection of characterizing of pollution microepisodes that would otherwise remain hidden. By combining continuous monitoring, daily heat maps, minute resolution analysis, and meteorological conditions, we were able to identify and characterize representative pollution episodes occur under different environmental conditions. The three cases studied present different scenarios. The first case demonstrates that the characterization of a reported industrial emission event. The second case illustrates a regional particulate matter 2.5 episode occurred under fog conditions. And the third case shows a regional pollution episode associated with New Year Eve activities. Although each event presents different characteristics, of all of them demonstrate that the value of high temporal resolution monitoring for understanding the dynamic of urban air pollution. In summary, high-resolution monitoring does not replace the conventional air quality index. Instead, it complements it by revealing the temporal evolution or pollution event and provide additional information that support environmental monitoring and decision making. We believe that this methodology can be applied to other industrial metropolitan areas to improve the identification and characterization of short-duration air pollution episodes. High-resolution monitoring does not replace the conventional air quality index. It complements by relevant pollution episodes that remain hidden after regulation averaging. Finally, I would like to thank my co-authors, my institution, and the organizing committee for the opportunity to present this work. Thank you very much for your attention. I will be happy to answer your questions. Have a good day.